Okay, so 10.5. We're skipping around, or I'm sorry, 11. 11. Wrong unit. Is about determinants and Kramer's rule.
What's that? Kramer, like
Not Seinfeld Kramer, no. Oh, sorry. So first we'll go over what determinants are, and then you'll see what they can be used for. One of the things that they can be used for. Okay? If we have a matrix A equal to, let's say, A, B, C, D, just a normal 2 by 2, then the determinant, and the notation for that is DETA.
The DE plus A or DET?
DET, like this.
So that just means
It means determinant, yes. Not to be confused with the D that's in here. Okay? Which also can be written as this. It's not absolute value of a matrix. If you see vertical bars around a matrix, it means determinant. So we could also write out the matrix and put vertical bars around it. All of this, no matter how you see it, means the same thing. Okay? This means determinant, this means determinant, and that means determinant, all for the same matrix. Okay, so just be comfortable with the different ways that you might see it. And the definition is that you simply, that's me messing up. Ignore. Okay, so to find the determinant, all you do is take A times D, and then you subtract the other product of the diagonal, B times C. Okay, this is the definition for a 2 by 2 determinant. It's an easy calculation to do. Here is 1, not 5 examples. So if A is, for instance, negative 1, 2, 3, 1, and I asked you to calculate the determinant of A, all you have to remember is to take the diagonals products and subtract them, but it has to be this order. Okay? So what would I multiply first? So negative 1 times 1, and then what do I subtract? 2 times 3. It doesn't. But this order here, like this needs to be there and this needs to be there, that matters. So we get negative 1 minus 6, which is equal to negative 7. Are there questions on how to calculate a determinant? If you're wondering what these are used for, I will answer that in a few minutes. Yes?
Is there a verse determinant when you do like BC minus AD?
No.
Oh, well.
Yes? Yes. I'll get there in a minute. Okay, good question. Question was, are we going to know how to do these for larger than 2 by 2? Answer is we will do a 3 by 3, but no more than that. Okay? On the calculator, see if you guys can figure it out. Let's say on the AC, and there was 1 year out of the past 3, I think. I mean, I know it was just 1, but 1 year where my pre-calc came back and said, there was a determinant question on the ACT, and we got it right. Yes, because we're the only pre-calc that actually reviews and does this. Okay? Maybe, what's that? In this class, in this building, yes. The 90s pre-calc don't do chapter 11, and they don't do chapter 12. You figure it out? So what do? You just
put the matrix in.
Same way as yesterday. Program it in there into matrix A, and after you program it, if you go to math, it's actually the first option, isn't it? DET, right there. Okay? All right. We good for a 2 by 2 determinant? Okay. Now, please pay attention. There are many ways to do a 3 by 3 determinant.
3 by 3.
I'm going to show you the one that always works. In fact, this could be applied to 4 by 4, 5 by 5. We're not going to do it, but it would work the same way. So let's say A is equal to, and we'll just do a 3 by 3 in alphabetical order. A, B, C, D, E, F, G, H, I. So the determinant of this matrix works like this. You take whatever A is, and now what you do is create a little 2 by 2 out of what is not in the same row and column as A. So if you visualize eliminating this row up here and eliminating this column right here, what little 2 by 2 is left? Good. So now what this means is you're going to take whatever A is, you're going to figure out this little determinant, which we know how to do now, right? How would you calculate this? E times I. Everybody understand? So instead of writing out all these letters for the formula, I'm just going to leave it like this because we know what this means, right? Now, here's where it gets a little weird, but the pattern always works. You take the next number in the first row, which is B, and you do the opposite of B, but it's the same idea with the little 2 by 2 now. So if you look carefully, wipe out the row that B is in and the column that B is in. Everybody see that? Okay. And now we go back to C, and then we add. So it actually alternates. If we had a larger one, like a 4 by 4 or 5 by 5, you would do positive A, opposite of B, positive C, or not, I'm sorry, I shouldn't say that. A, opposite of B, C, opposite of D, and so on. It just alternates back and forth like that. And you keep reducing it to a smaller determinant, and then keep reducing it even more. But this is all we need to know. We're only going to do... Yeah. And then, okay, so same thing. Cross out the row and column that C is in. What's left? D, E, G, H. Okay, so we'll do one quick 3 by 3 example by hand. We'll confirm it with the calculator, and then we should have time to see a quick application of this. Yes?
Do they need to have like 3 by 3 or 2 by 2 at the same row columns?
Yes, it needs to be a square matrix. Excellent question. Square matrix meaning it's got to be 2 by 2, 3 by 3, 4 by 4. Okay, it's not.
1 by 1?
Well, it would just be no. You could. It'd be itself. A 1 by 1 matrix. That's a good question.
I realized what I asked after I said it.
Okay, so here's a quick example. Let's say A is 1, 2, 2, 0, 3, 1, negative 2, 4, negative 3. And we want to calculate, what does this mean? Determinant of A. Okay, so I'll follow the same motto here. First I take what number? 1. And now I'm going to create a 2 by 2 determinant out of 3, 1, and 4, and negative 3. Does everybody see that? Yeah.
That number on the outside, do you multiply it by?
Yes. So first you're going to figure out this determinant, and then whatever number you get, you multiply it with this scalar, or this coefficient. All right, so what comes next?
2. Minus 2.
Minus 2. It's the opposite of whatever we see here. And then what 2 by 2 determinant?
0, 1, negative 2, negative 3.
You guys sound so excited. 0, 1.
It's because math is
Okay. What's the next?
plus 2.
Plus 2.
0, 3, negative 2.
Oh, shoot. Wrong color.
Oh, no. Oh, no.
Okay, so now we've set it up. Now we just figure it out. So how do I figure out this determinant? You do 3 times negative 3, which is negative 9, and then you subtract what? 4 times 1, which is 4. Make sense? Minus 2, and then what do I write here? 0 minus negative 2. Plus 2, and then here I get 0 minus negative 6. And now it's just order, simplify, order of operations. We get 1 times negative 13. 0 minus negative 2 is 2. 0 minus negative 6 is 6. So this is the same as negative 13 minus 4 plus 12, which is negative 5.
Yeah.
Because it's a negative 6.
No,
Wait.
Exactly. My part is minus.
Plus
We okay?
At least these.
Any questions on how we set this up and how we calculated all the little pieces here?
No.
Okay? Take 30 seconds, program a 3x3 in there, and let's just make sure we can do it on the calculator too.
This is legit. I cannot do this one. I have a calculator. Wait, what? Dude, it's so easy.
John, come in and see me sometime outside of class.
I'd rather do it by hand. Is that fine?
Have fun not finishing the quiz. And I don't mean that to be mean. Like, you need to know how to use the calculator. If you're doing everything by hand, you're not going to finish.
I was almost quicker than
Okay.
negative 5.
We getting the same thing? All right. Now, here's Kramer's rule.
Was he an actual dude? Is he
Yes.
like a mathematician?
It is. And here's what it works. Okay? This is a new method for solving systems that some of you may not have seen. But let's just go ahead and write it down. If we have a system, ax plus by equals c, we'll start with a basic 2x2. And dx plus ey equals f. The solution, according to Cramer's rule, can be calculated by doing determinants. So there's actually no manipulation. Like, you don't move stuff around, eliminate. You don't have to do anything. You just do determinants. And here's what it looks like.
But it's a 2x3.
Well, no, if we're not doing RREF, it's 2 variables, 2 unknowns. Okay? So here's what it would look like. Here's what I'd like to write down. D sub x, so we're going to use x as a subscript, divided by d. That's your x answer. And I'll explain what this means. And then y would be pretty much the same, d sub y over d.
Just like no eliminating.
There's no elimination at all.
Or I mean, if you're dividing dy by d, then just gives y. No, because y.
Here's just, hold on guys, I'll answer what all this stuff means in just a second. Okay? And then here's what everything looks like. D is the same in both of these, and D is simply the coefficients of what you see on the left-hand side. It's a 2x2 matrix, and you just write down the coefficients of x and y. So what would we do?
1.
A, B, D, E. Okay? D sub x. Listen carefully to how we create it. Okay? What you do, if you're looking for D sub x, you get rid of the x column, but you put the answer column in its place. So instead of A and D, we'd have CF in the x column, and we leave Y as BE. All you do is replace the x column with the answer column, which is CF. And then for D sub y, Yep. So we're going to leave the X column, which is AD, but now instead of B and E, we're going to replace it with the answer column, which is C and F. Okay, this is Kramer's rule. Watch how easy this is. It looks, yes.
Can you do this over 3 by 4?
You mean 3 by 3s?
Well, I mean, like,
Yeah, the larger they get, it's the same rule, it's just you have more going on. So yes, this applies to 3 by 3s and so on. So now here's your quick example. We'll do another one that's got an easy answer, like x plus 3y equals 5. X plus 3y equals 5. 2x minus 3y equals 1. Okay? According to Kramer's rule, I'm just going to do a little fraction on the top. If I'm looking for x, I don't use the x column. What do I use? 5 and 1. And then the y column stays 3, negative 3. The bottom is always just the regular coefficient. So we're going to write down 1 and 2 for the x column and 3 and negative 3 for the y column. If we go ahead and calculate this, we get negative 15 minus 3. Everybody with me? What's the bottom going to be? Negative 3 minus 6. And now we just simplify. We get negative 18 over negative 9. So x is 2. And now we do a very similar calculation for y.
oh, that's just that.
Yeah, we're done. We don't have to do anything except that. What's the 2 by 2 determinant in the numerator now? We leave the x's alone.
So 1, 2,
But now if we're looking for y, we put what in its place?
the answer.
The answer column, which is
5 and 1.
5 and 1. The denominator is still the same 1. It's just the normal 1, 3, 2, negative 3. Okay? So what's the top? 1 minus 10. We already know the bottom because we figured it out. It's negative 9, right? So it's just negative 9 over negative 9. So the answer is 1. So our solution is 1, 2. Oh, I'm sorry. You're right. 2, 1. I know that was kind of quick, but that's it. That's all that there is in the section. Okay?
So we're done with the section?
We're done with the section. Farewell.